let's say, okay, Bernoulli's principle is the states that when the velocity of a thing increases, a fluid increases, its pressure will decrease. For fluid. So yeah, when the velocity of a fluid increases, the pressure of the fluid decreases, and vice versa. So for example, kan, if I were to blow air into this paper, into this hole, when I blow air, then air goes at a fast velocity, kan. So when it goes at a fast velocity, this thing has low pressure. So when it has low pressure, air will go from the high region of pressure to the low region of pressure. So air will push downwards because it has to go from high to low. And then for here, if you don't blow at the paper, you blow directly above the paper. And then when you blow the paper directly above, you will realize that the paper goes up slightly when you blow it. That is because when you blow, it produces a region of low pressure here. Then the high pressure region will try and balance it out. So it will go upwards. The paper will go upwards. And then for this is the main example, the tube. So this level, these levels, right? They represent the pressure of the water level and the pressure of the water at that region. Why do you know it's the pressure? Because remember that pressure is equal to rho GH. Yeah, rho GH. Okay, so we know that it's equal to rho GH. So this is rho GH. This whole thing is rho GH. So the higher the level, the more the pressure. So X has the most pressure, and that means it has the lowest velocity. There is no reason why. It's only because others are faster. So A is basically the control or something like that. It's the main reference. So yeah, at first when you do the experiment at first, it will be at like these levels. Yeah, remember water level is equal in a normal pressure in a normal region. Right, when water is not moving, they will all have the same water levels. If you look back, it doesn't matter. Doesn't matter how they look like, how wobbly it is, how zigzaggy it is. They will all end up at the same level if there is no if there is no external environment. But then when an external environment does happen, like in this case, the water tap turns on. When the water tap turns on, it will cause the velocity of this thing to increase. It will cause there to be a change in velocity. So if you look at this, the water levels of A will slightly drop because the velocity changes, so velocity is increasing, pressure is decreasing, so the water level of A drops a bit from here. Just a little bit. Okay, wait. No. It doesn't. Water is already flowing, Water is already flowing. But the difference is, you want to try and make it full first. You want to try and make it full. Actually, wait. Yeah, I think it increases slightly. Because you increase the water pressure to a certain level, right? And then, because after you open the clip, then the water will flow to the sink. So when the water flows to the sink, right, you will see that the water will move from this side to this side. Like from here, you fill it up first. So at this time there is no velocity yet. But after this, there is velocity. So the pressure will decrease. So the level of A will decrease slightly. But again, even if it's wrong, that doesn't matter anyway. The main point is B and C. Why are B and C's levels lower than A? B and C's levels are lower than A because the velocity of the water flowing through here is higher. How is it higher? Simple terms. I think it wrote it somewhere. Let me just see where it wrote. Yeah, I saw it written down somewhere. Oh, here. When a fluid flows continuously in a pipe, the smaller the diameter, the higher the velocity. So you see that this thing has a small diameter. So the smaller the diameter, the faster the velocity. Now, why is that so? From my teacher's explanation, it goes like this. Like, suppose you're in the school car and you want to go home. And like everyone wants to go home at the same time, can, but the stairs is so small, so you have to squeeze through. So when a lot of you are like together, can, and you try to squeeze through, you become faster around the stairs, cause like you want to go down fast. You feel like you should go down faster because a lot of people are behind you. So it's the same thing here. The water molecules are all cramped up together, so the water molecules bump with each other. When they bump with each other, it increases the speed of the water molecules. So when it increases the speed of the water molecules, then the velocity becomes lower, lor. Then the pressure becomes lower, lor, because the velocity is high, ma. And then for z, why is z lower than x? Because the velocity is still here, kan? It slows down, but it doesn't slow down that much. It's still kind of fast, so it's slower. So it's slower. So that's why the water column height is higher at A than at C, because water is slightly faster at C due to the water coming in from B. I mean, that's how I understand it, at least. Okay. Now, how do you apply it in normal stuff? First of all, ping pong ball. So so ping pong ball. When you blow air through this tube gun, the velocity here will be high, right? That means here is low pressure, here is high pressure. So therefore, the ping pong ball will get lifted up. Okay, so that you have to consider that there is a hole here. So most of you might be wondering, wouldn't the air go through and then lift this up? No, it doesn't, because there's a hole here. So the air will go out immediately. So how does it go up even with the hole? That's because here is a high velocity region. High velocity means low pressure. High pressure goes to low pressure, kan? So the air from the high pressure goes to the low pressure. So the ping pong ball gets stuck with it. Like it gets dragged by the air. So that's why it lifts up. And if you have enough speed on your blowing, it will get stuck. Okay, then there's the aerofoil stuff, the aeroplane and things. Oh no, I don't really want to talk about this. Okay, something to do with kan. Okay. The way the way the wing is shaped causes the velocity here to be higher. Like the way the wing is shaped, the way the wing is shaped, kan, it causes the velocity thing to be higher at the upper part of the aerofoil, while the lower part is lower. So of course, high pressure to low pressure. So since it's high pressure to low pressure, it causes the force to go upwards. So like in the aeroplane, kan, the aerofoil helps with the aeroplane to take off. And then some people make an upgrade where they add where they add a certain angle. So when they add a certain angle, let me see here. When the aerofoil is at a certain angle of attack, the aerofoil exerts a force on the airflow. According to Newton's third law of motion, a reaction force will act on the wing of the aeroplane and contribute to the lift force that's on the aeroplane. So what this means is, when air flows into here at a certain angle, right, then the airflow will hit the aerofoil, bukan? So when the aerofoil punya air, when the airflow hits the aerofoil, it causes force to be acted on this part. So we call that a drag. We call it drag. And then wait, let me see here. Oh, because it's the other way around. Because remember, when you're flying, kan, when you're flying, right, what are? Okay, I'm repeating the same thing again. Okay, when you're flying, your thing moves at a fast velocity, kan? And then if your air flows at a certain angle, it will act onto it. Like the aerofoil will try and push the air out. So when the aerofoil tries to push the air out, of course there will be a natural reaction, a normal reaction, and the airflow will try and push back. So that will cause drag. But the drag is actually not at this angle, it's at a certain angle around here. And remember the whole resolution of forces thing. So it helps in lifting the aeroplane. So when it's at a certain angle, when the aeroplane flies, and the aeroplane punya aerofoil clashes with the air force, there will be a natural reaction causing